Hey guys, Goggle Man back again, and we're back with another geography lesson. This is going to be, I'm going to try and make this quick because I want this quickly in my brain, and I want it to be quick in your brain too. You're going to remember this by the way I say it. This is a sample answer to the question, examine the global distribution of volcanoes. This is worth 30 marks, okay? So, here we go. Plate tectonics, okay. Determine the global distribution of volcanoes all over around. They are located at three locations. Converging boundaries, diverging boundaries, and hotspots. Okay, hotspots. Remember, hotspot on your phone, okay? The Pacific Ring of Fire is the most active volcano zone in the whole world. Most active. Pacific Ring of Fire, most active. Okay, do you remember everything else? Okay, you better. Volcanoes occur at constructive divergent boundaries as plates pull apart from each other. Pressure from convection currents and gases in the mantle force the magma upwards through the fissures. Okay, the fissures. Magma, convection currents make the magma rise up just like that, okay? As the plates separate, I wrote that weirdly. The fissures in the crust allow much of the volcanic gas to escape. This means that the eruptions are not very volatile, releasing basic lava. I don't know if I got that right, so I'm just going to say violent every time that word pops up, okay, guys, because I'm just dumb. I shouldn't be dumb, but, here we are. This lava cools quickly in large blobs known as pillow lava before hardening to form basalt rock. Okay, we all love basalt rock. Example of this is where the Eurasian and North American plates separate to form the Mid-Atlantic Ridge. Okay, Mid-Atlantic Ridge. That is the example here. All right, next one. Volcanoes occur at convergent destructive plate boundaries as two plates collide with each other, causing subduction. Remember, I always think of this in my head when I'm doing it. Subduction. It goes under like that, just really like this. So when I'm in the middle of the exam and I'm thinking, fuck, what's the next thing? I'm gonna go subduction. It's subduction. It goes underneath. It subducts under the other one. As the heavier oceanic plate subducts into the mantle, it begins to melt. This forces magma upwards towards the lighter overlying plate to form a magma chamber. A magma chamber, guys. The magma has a high silica content. This makes it thick and pasty, which means that the violet gases cannot escape. As a result, pressure begins to build, leading to an eruption. The pressure in the magma chamber. Just remember that, guys. Example is the Nazca plate, subducting beneath the South American plate, forming the Andes. Okay, remember that. Now we have volcanoes or hotspots. Volcanoes or hotspots form away from plate boundaries on both continental and oceanic plates. Hotspots occur due to unusually hot plumes of magma rising through the mantle. Okay, remember that? The magma rises through the mantle. That literally makes it melt, guys. The magma is so hot that it begins to melt through the plate. The basic lava is very runny and flows very quickly away from the vent. Remember, Among Us, Sussy, and Boster goes through the vent, just like the basic lava. It flows very quickly away from the vent before cooling on the surface. It cools on the surface, guys. That's awesome. Volcanoes or hotspots are very gently sloping and are often referred to as shield volcanoes, e.g. Hawaii. I don't even know if that's right. That's just what's written in here. All right, I'll see you guys next time. No Subway Surfers this time. We're getting serious. Bye-bye.